Hello there, welcome back. This is the first video in our bonding unit. So bonding is a pretty long unit. We actually break it up into two parts. Unit 3A, which we're starting now, covers ionic bonds and metallic bonds, whereas Unit 3B talks about covalent bonds and molecular and bond polarity, as well as intermolecular forces. So this video is part of Unit 3A, and it is titled Lewis dot diagrams of atoms and ions. So in the last series of videos, we talked about periodic table. So just because we're done with this doesn't mean we are completely done with it. Stuff that we've learned, you can't just forget about it and never think about it again. A lot of these topics do kind of build and need that prior knowledge. So again, today we're going to cover Lewis dot diagrams and how to draw them for atoms and ions. So Lewis dot diagrams are basically used to show the valence electrons in an atom or ion. Remember, valence electrons are the outermost shell. So if we had something with the electron configuration 2-8-5, how many valence electrons does this have? So you should say 5 valence electrons, and that would be perfect. So again, the last number in the electron configuration, that is your valence electron number. Again, these are used to show atoms, ions, and compounds. So these are actually super simple to do. When we're talking about atoms, remember atoms are neutral, so everything is, as it says on the periodic table. So if we're looking at oxygen, first step is to draw the element symbol. Oxygen is O. Then it says determine the number of valence electrons. Well, oxygen has the electron configuration 2-6. So how many valence electrons does this have? You should say 6. Okay. And so then we're going to fill this in exactly the way we did with Bohr diagrams. Top, right, bottom, left. And then that only gives home to 4 of the electrons, so we have to give it the last 2. Oops. You do 1, 2. And that's it. So it's super important that you're doing this in this way. You're going, in that clockwise fashion, and then going around again should you need to. So if we're looking at carbon, carbon is C, so we did that. Carbon is the electron configuration is 2-4. So how many valence electrons does carbon have? You should think 4. And then you do 1, 2, 3, 4. And that's it. Okay. Next, let's try magnesium. So magnesium is Mg, has the electron configuration 2-8-8-2. Sorry, just 2-8-2. So it has how many valence electrons? You should say 2 valence electrons. So 1, 2. And again, that is it. Let's finish it up with one more atom, chlorine. Chlorine is Cl, has the electron configuration 2-8-7. So how many valence electrons does chlorine have? You should say 7. And so then you go 1, 2, 3, 4 by themselves first, and then with the buddy to have 7. So again, if you're not doing this in this method, then it becomes more difficult and it opens up doors to get questions wrong when we use these to build compounds. Okay, so let's talk about cations. Cations are positive. You could even say they are positive. Remember, cats have posits positive. And these are formed by metals, and when metals lose electrons. So if we look, for example, at sodium, the electron configuration for sodium is 2-8-1. So sodium has one valent electron. It wants 8. All atoms want a full stable valence shell, and for most elements it is 8 electrons. But for sodium and any metal, it's easier to lose that last shell. So to lose 1, 2, or 3 valent electrons than it is to gain 5, 6, or 7 of them. So with this shell gone, now its second to last shell, which is currently now its last shell, is full and stable. So again, metals are cations, positive ions because electrons are lost. So if we look at this 2 plus sign, this tells us a lot of stuff. So that positive means electrons are lost. Remember, electrons are negative. If you're losing these negative feelings, these negative things, you're more positive. And the number tells you the actual number of the electrons lost. So if you have plus 2, that means you have 2 electrons lost. What would plus 3 mean? If something had a plus 3 charge, what does that mean? Hopefully you said 3 electrons lost, which would be correct. And what if I wanted to say that 1 electron was lost? What would I say there? How would I write that? If something lost 1 electron, it would have a plus 1 charge. So if we're going to go ahead and draw these dot diagrams for cations, it's super simple, but I'm going to show you the kind of long way to and how stuff works, but there is a shortcut which I will show you. So calcium is Ca. Its atom has the electron configuration 2-8-8-2. So again, it has 2 valence electrons in the atom, but it wants that full valence shell. So what's going to happen in the ion? It's going to lose that original shell. So its ion would be 2-8-8. But when we're drawing the dot diagrams for cations, we're drawing this original shell that disappeared. So now there's nothing to draw. So all you have to do is add brackets and a plus 2 charge. So remember, plus 2 just means you had 2 electrons lost. And if we're looking at this, here's the shortcut. Whenever you see a positive sign, that just means all the valent electrons have been lost. So all you have to do is write the charge and then add brackets. There are no dots for cations. No dots. So if we're looking at rubidium is Rb. And if we're going to do this the short way, we just need the brackets and a charge. It's in group 1, so it has a positive 1 charge. So if we're going to look in this in a little bit more detail, rubidium has the electron configuration, the atom has the electron configuration of 2-18-8-1. Remember, it's going to lose that 1. And so that's where that plus 1 charge comes from, meaning it lost 1 electron. And for positive cations, you draw no dots, just a bracket and the charge. And that's it. Okay, so let's cover this last little bit of section talking about anions. Remember, anions are negative. They're formed by nonmetals. Remember, anion looks like onions. Onions make you cry. Crying is negative. So, in order to become negative, you have to gain more negative electrons. So if we're looking at any of the nonmetals, you have, 4, 5, 6, 7 valent electrons. It's easier to gain the last few to make that perfect 8 than it is to lose that many. So if we're looking at this symbol, if we're looking at nonmetals or the anions of nonmetals, you'll see a negative sign, and that negative sign means it's negative because electrons were gained. And that number tells you the number of electrons that were gained. So a negative 2 would mean 2 electrons are gained. What would minus 1 mean? Hopefully you said 1 electron gained. And if we had, 3 electrons gained, what would that be? that would be 3 minus. Again, minus tells you electrons are gained, the number tells you how many are gained. So when we're drawing dot structures for anions, there's a shortcut, and I'll show you that shortly, but let's go about it the long way. So oxygen is O, and the electron configuration is 2-6. Remember, this is your atom. So with that 6 valent electrons, the oxygen atom will gain 2 electrons to make that perfect 8. Now that would be your ion. And if you're gaining 2 electrons, that's that 2 minus. So gain 2 electrons. So when we're drawing this, we do 1, 2, 3, 4, 5, 6. So those red dots represent the electrons from the atom. And then the blue dots, you don't need to color code this, I'm just doing this to show you, are the extra 2 that were gained. So to finish this up, add brackets. And to show that something funky is going up, add that -2 charge. So brackets are used for any type of ion, positive or negative. That's just to show that something's not quite right. It's kind of weird. It's not normal. It's not a normal atom. And again, that charge tells you how many electrons were either lost or gained. If it's negative, electrons were gained. If it's positive, electrons were lost. So remember, here's the shortcut. If it's negative, that means you gained and you filled in that valence shell. So just draw 8 dots right in the charge and the brackets. That is it. So if we do one more, and let's just even do it the short way. Chlorine normally has the atom, has 7 valence electrons. We want 8, so 1, 2, 3, 4, 5. Actually, let me draw it the proper way. 1, 2, 3, 4, 5, 6, 7. So there's that atom. Remember, it's 2-8-7. In order to get that full valence shell, it needs to gain 1 electron. So that gives you that -1 charge. There's an extra electron, -1 charge, and those brackets. So we're going to continue with this more. So if you're a little bit confused, it is okay. In the next lesson video, we'll talk about ionic bonds, what it is, what it's made of, and how it is formed.